One of the first things I do when diagnosing CEEMATs is climb into the seat, and then I take it for a test drive or use a handheld tool to actually isolate any problems before I get my hands dirty. Once you understand the three systems and how they work together, you can use the electronics to quickly find out any problems within the transmission. It makes the job a lot easier because you know what you're looking for before you crawl into the truck.
This program will help you, the professional truck technician, understand the theory behind the Eaton-Fuller CEEMAT transmission, the whys and hows. We'll show you the similarities between the CEEMAT and the transmissions you're used to working on. But more importantly, we're going to crawl through a CEEMAT to show you how they're different. Because when you've touched every part of the system, chances are you'll recognize when it's working right and when it's not. Before we get into the details, let's start with a little background information. CEEMAT stands for the Converter Enhanced Electronically Managed Automatic Transmission. Converter Enhanced means a torque converter replaces the master clutch. There's no need to press the clutch pedal at idle. And the torque converter gives 2-to-1 torque multiplication during startup. Electronically managed means a transmission-mounted electronic control unit, or ECU, controls all the shifting. And automatic transmission means just what it says. The transmission does all the upshifts and downshifts by itself. The driver doesn't work a clutch or a shift lever. Now, the CEEMAT starts out as a Road Ranger 9-speed transmission. Well, as you can imagine, in order to replace driver control to create an automatic transmission, Eaton-Fuller had to add a few components. You can review them in detail in the workbook that comes with this tape. But for now, let's get an overview. In a CEEMAT, a torque converter replaces the clutch and allows the engine to idle while in gear. The torque converter contains two clutch systems. An interrupt clutch replaces the master clutch, disengaging the engine from the transmission during shifting and in neutral. And a lock-up clutch couples the transmission directly to the engine, bypassing the torque converter. A synchronizer system matches transmission input and output shaft speeds to provide smooth, high-quality engagements. An auto shift module selects the gears using the same shift mechanism as a Road Ranger transmission. And as we said, an electronic control unit, or ECU, controls the entire system: clutches, auto shift, and synchronizer. Now, for the sake of comparison, let's take a slowed down look at how a driver handles a startup and non-automated shift. Bet you'd never looked at it this way. All right, the driver presses the clutch pedal, allowing the engine to idle while the transmission is in gear. He releases the clutch to get rolling and watches and listens for the correct time to shift. Then he presses the clutch pedal, defuels, and pulls the transmission to neutral. In neutral, the driver releases the clutch pedal while at the same time working the throttle to adjust engine RPM to synchronize transmission and engine speed. He presses the pedal again, selects the gear, releases the clutch pedal, and gets back on the throttle. And depending on road and load conditions, he does all of that in around 3 seconds. And of course, he continues the whole process throughout the shift cycle. Now, it would seem pretty logical at this point to show you how the CEEMAT works by doing a run-through like the one we just showed you using the manual transmission. Well, we're not going to do that yet because there's a better approach to understanding the CEEMAT. You see, the CEEMAT automated transmission does the same things a driver does with a manual transmission. Idle in gear, take off, declutch, defuel, synchronize, select a gear, reapply the clutch, and refuel. But it does it using three systems: a hydraulic system, a pneumatic system, and an electronic system. Understand what these systems do and what components make up each system, and you'll understand the CEEMAT. The first system that we want to talk about is the hydraulic system. Simply put, it replaces the clutch. Hydraulic system components include the hydraulic pump, the torque converter assembly, which houses the interrupt and lockup clutches, and hydraulic valves. It works like this. In the hydraulic system, the torque converter transfers power from the engine through a viscous or fluid coupling. Compare this action to two household fans. Airflow from the first fan spins the blades of the second fan. Now, the interrupt clutch connects the torque converter with the transmission input shaft and has the same function as the master clutch on a non-automated transmission. Whenever the truck is running over 12 miles an hour, a lockup clutch bypasses the torque converter, so engine torque is coupled directly to the transmission input shaft. This provides maximum efficiency. Now, you need hydraulic pressure to operate the transmission. A hydraulic pump geared to the torque converter supplies pressurized fluid to the hydraulic valves. The valves, which are controlled by the ECU, operate the interrupt and lockup clutches and direct lubricating fluid to all transmission components. The hydraulic valve also contains pressure regulators to control hydraulic pressure throughout the system. The CEEMAT pneumatic system synchronizes and shifts the transmission using the truck's air system. It includes the auto shift module, synchronizer system, and range system. Now, the auto shift module replaces the conventional gear shift lever. Two side-by-side solenoids mounted on the auto shift select the correct shift rail. Fore and aft solenoids, also mounted on the auto shift, select the correct gear. The CEEMAT synchronizes the transmission using solenoids mounted under the ECU cover, and one of two methods, depending on whether the transmission is operating with a mechanically governed engine or an electronic engine. This is how it works. During downshifts with mechanically governed engines, you need to increase the speed of the front countershaft. The CEEMAT uses a power synchronizer to do this. You see, the power synchronizer is splined to the front countershaft. Using its band clutch, power is directed through the power synchronizer's planetary overdrive transmission to speed up the front box countershaft. This power synchronizer assembly also includes brake discs that slow down the countershaft during upshifts. The ECU pulses air pressure to the disc brake, momentarily grounding the countershaft to the transmission case. Pulsing the air pressure is like pumping the brakes. It slows the shaft gradually rather than locking up completely. Now, CEEMAT transmissions can communicate directly with the electronically controlled engines, which means they don't use a power synchronizer. They have an inertia brake instead. The inertia brake is geared to the front box countershaft. To slow the countershaft during upshifts, the ECU pulses air pressure to the inertia brake disc pack, slowing the countershaft, the same as the power synchronizer disc brake. For downshifts, the primary difference with the electronically controlled engine is that no separate device is needed because we can boost the engine, which speeds up the front box countershaft. Finally, the range system pneumatics are controlled by a slave valve mounted on the ECU and operate the range shift mechanism, which is identical to a non-CEEMAT Road Ranger. The third CEEMAT system is the electronic system. This system selects the best time and the best way to shift and monitors and controls the hydraulic and pneumatic systems. Its specific components include the electronic control unit, or ECU, sensors, torque converter harness, auto shift harness, and vehicle interface harness. Now, these are the components of the electronic system, but you should be seeing the way the three systems relate at this time. For instance, the torque converter harness is the connection between the ECU and the hydraulic section. The torque converter harness carries output signals from the ECU to the hydraulic valves. Remember, these valves operate the interrupt clutch and lockup clutch, part of the hydraulic system. And the torque converter harness carries input signals coming from the engine speed sensor. The auto shift harness also carries input and output signals. There are two types of input on the auto shift harness. The first input is from the ball switches, which signal the current gears position to the ECU from the auto shift and the range shift. The second type of input is transmission shaft speed. Two speed sensors mounted on the shift bar housing signal input shaft and output shaft speeds. The auto shift harness outputs are to the four solenoids that control the auto shift module. The vehicle interface harness connects to other inputs and outputs that tie the transmission to the rest of the vehicle. For instance, the input signals from the service brake and the throttle position sensor are on the vehicle interface harness. And the ECU outputs signals to the throttle control solenoid and to the service transmission light through the interface harness. And when coupled with an electronically controlled engine, the communication between the CEEMAT and the engine is through the vehicle interface harness. The ECU controls all three systems: hydraulics, pneumatics, and electronics. Now let's look at how CEEMAT brings together these three systems and their corresponding components to complete a shift. Again, the CEEMAT transmission does the same thing a driver would do: declutch, defuel, synchronize, select a gear, reapply the clutch, and refuel. But here's how the CEEMAT does it. When the ECU determines it's time for a shift, the interrupt clutch is disengaged by releasing hydraulic pressure in the hydraulic valve. Engine speed is decreased using the defuel solenoid on mechanical engines or using the communication link on electronic engines. The auto shift pulls the front box into neutral. The ball switches confirm that the front box is in fact in neutral. The synchronizer system, meaning the power synchronizer disc brake on mechanical engines and the PTO-mounted inertia brake on electronic engines, manipulates the speed of the front box countershafts to match engine and driveline speeds. When input and output shaft speeds reach synchronous, the four solenoids mounted on the auto shift select the correct shift rail and gear position. The ball switches provide feedback to the ECU that the proper gear is engaged. The engine is refueled using the defuel solenoid on mechanical engines or the communication link on electronic engines, while the interrupt clutch is re-engaged. And keep in mind that over 12 miles an hour, the torque converter lockup clutch engages, bypassing the torque converter to send engine power directly to the transmission. And remember, during downshifts, synchronizer operation is different. On mechanically controlled engines, the ECU doesn't increase engine speed. Instead, the ECU operates the band clutch in the power synchronizer to speed up the transmission countershaft speed to match engine speed. And on electronically controlled engines, the CEEMAT ECU signals the engine control computer to increase engine speed during downshifts, just as a driver would do on a non-automated transmission. CEEMAT does everything a driver would do using a manual transmission, but in a fraction of a second. And with the CEEMAT, all the driver has to do is release the brake and hit the throttle. Let's take one more look. During both the manual and CEEMAT shift sequences, the transmission has to declutch, defuel, synchronize, select the gear, reapply the clutch, and refuel. But again, the CEEMAT does it in a fraction of a second. For a different look at CEEMAT operation, your workbook includes graphs and detailed information. You'll also find the other tapes in this series useful. Driver instruction will show you how to operate the CEEMAT in various real-life applications and will highlight some special features. The diagnostic and troubleshooting tapes will show the specific procedures to follow in pinpointing the cause of any malfunction. We'd love to say you'll never have to work on a CEEMAT, but this is real life. So for those times when you do have to work on a CEEMAT, we hope this program and the accompanying materials have been helpful. If you have questions, you've got the magic of video at hand. You can review the material as many times as you'd like. Refer to the detailed material in your manual. And of course, you can always count on the help of your Eaton Road Ranger National Support Network. 1-800-TCM-HELP, just in case you need it. Eaton, technology you can depend on.